Today we're going to learn about arithmetic sequences. An arithmetic sequence is when you have a few numbers that a difference between them is the same. So we're going to have a lot of patterns going on where we're going to have to continue on a pattern. Now, the common difference is what is very important to us in an arithmetic sequence. It's the difference in between the numbers, and it's found by adding the common difference to the previous term. So you're adding. So it could be a positive number or a negative number. So let's go into examples. The first part says extending an arithmetic sequence. So write the next three terms of the sequence and then find the common difference. So we have to find all of that. So as we're looking at the first one, I see that it's getting smaller by 7 each time. Now remember, we're adding the common difference. So our common difference is -7. Now we just have to go through and write the next three terms. So the next three terms would be -35, -42, and -49. Let's do it to the next one. The next one we see we're going up by 12. So our common difference is +12. And to write the next three terms, we have 36, 48, and 60. Go ahead and do the same thing to the next two problems and check back with your answers. All right, so here are the answers that I got. The first one, the common difference was 0.4 or 4/10. And so I wrote the next three in the sequence there. And then the second one, I got -1/4. So it was going down each time by subtracting 1/4 or adding a -1/4. And those are the next three terms there. Now we're going to take it one step further. We're going to write the next three terms and then graph the sequence. So we're just going to make this into a T-chart. And the X value is actually the term that you have. So we have 4 as our first one. So our first term is number 4. Our second term is 8. Our third term is 12. And our fourth term is 16. Okay. Now they do want us to write the next three. So as we're looking and we're seeing what's being added, we know that the common difference is 4, +4. So my next three terms would be 20, 24, and 28. So I could add that also into our T-chart. So our fifth term in the sequence is 20, our sixth term is 24, and our seventh term is 28. So we're going to start seeing what this looks like when we actually graph this. So I'm not going to be able to graph all of these numbers to go all the way up to 28, but I am going to graph a few. I'm going to go up by ones on my y-axis, but I'm just going to label it so it's easier for me to graph. And then I'm going to spread it out a little bit on my x-axis just so I can see it a little clearer. All right, so then I graph these points where my first term was 4. And my second term was 8, and I know I'm going to run out of room, but that's okay. My third term was 12, and that's where we can stop. Okay, so as we graph this, you guys can see that although my line wasn't the straightest, an arithmetic sequence makes a linear line. So we are going to have a linear function. We're going to make straight lines with an arithmetic sequence. Go ahead and try the next one on your own. Don't forget to write the next three terms in the sequence. All right, that's what the graph should look like for you guys. It's another line. We're going up by 3s, so you should have 15, 18, and 21 as your next three terms, and then the graph is a straight line. Go ahead and do the same thing with these two graphs. On that second one, you're going to have to write in your scale for the y-axis because we do have some decimals. All right, this is what your graph should look like, and make sure that they are straight lines and they're labeled correctly. Now we're going to use equations to help with our arithmetic sequences. So up above is the important equation that you guys should know, okay? And that's going to help us see what different numbers we have in the sequence. So we can find what the 50th number in a sequence is, not by graphing it or by doing each step of the way, but by plugging the things into the equation that we actually know. All right, so in this equation, it tells us what's going on, but D stands for that common difference. So if the common difference is -4, we plug in -4. N is the number of the sequence, and A to the first is the first term of that sequence. Okay, so this A to the N that we see, that's going to be like, hey, go ahead and find the 50th number. So that N is going to be that 50 spot. Okay, so down below, we're going to write an equation for the given sequence, and then we're going to find a 25. So we're going to find the 25th sequence or number in that sequence. So first off, we do have to find out what the common difference is. So we have 14, 211, 28, 25. So our common difference, which now I'm going to start labeling as D, is -3. Okay, and we have that our first term in our sequence is 14. So the first thing we do is plug all of this in and write the general equation for the sequence. So it is AN equals, our first term is 14 plus, in parentheses, n minus 1 times -3. Okay, so that's what we plug into the sequence, but we can definitely reduce it or simplify it. So we go ahead and do that. I'm going to distribute this -3. So I'm left with 14 plus a -3n, or it could be just -3n plus 3, because -1 times -3 is positive. Then when I combine my like terms, guys, you're going to see something a little interesting. I'm left with this. It's in slope-intercept form. Our slope is -3, which makes sense. That's our common difference. And our zeroth term, remember, think about if we went an opposite way, is going to be 17. So on our y-axis, we'd go to 17. So that is what the equation would look like. Now we have to find a 25. So we just plug in 25 into our n spot. So A of the 25th term is -3 times 25 plus 17, okay? So when we find that 25th term, it becomes -75 plus 17. And then when we go ahead and do that, it is the 25th term is -58, and that's our answer. So I'm going to go ahead and do the next one also with you guys. So we're looking for the common difference between 4, 5, 6, and 7. Okay, so obviously we're adding one each time. That is going to be that common difference. So we plug that into our equation, and also we know that A1, the first term, is 4. So we have that A to the nth power equals our first term, which is 4, plus n minus 1 times our common difference, which is 1. So I am going to distribute, and when we simplify all of this, I start getting into my slope-intercept form equation. And then I combine my like terms of -1 and 4. And our final equation for this sequence is n plus 3, which makes sense. If we were to go to the y-axis, we would go to 3, and then our slope is 1. We go up 1 every time. Now we have to find the 25th number in the sequence. So A25 is equal to 25 plus 3, because we just plug that number in. So the 25th sequence, or number in the sequence, I'm sorry, is 28. And there you go. Go ahead and do that with the next two problems. All right, so these are the two answers that you should have gotten. Don't forget that you also have to find the 25th term in the sequence. So when you get these kind of questions, I'm looking for the equation that's in slope-intercept form, but also that specific number in the sequence. Now we're going to do a word problem. So let's talk about online bidding. So online bidding for a purse increases $5 for each bid, and $60 is the initial bid. So we're going to write the equation for the nth term of the arithmetic sequence. The first thing you do is figure out what your common difference is. Well, if it's $5 for every bid, that is what the common difference is. And then your first term is $60. So you're going to plug that into that equation.
That's how that works.
Yeah.
So it doesn't record your base.
So our equation of a to the nth power equals, our first term is 60, plus we have n minus 1, and then our common difference is 5. So let's go ahead and put this into slope-intercept form. We're going to simplify it and get it into that correct equation. So I'm just distributing that 5, and then now I'm going to write the final equation. So 5n plus 55. So that's the final equation. Now, this part B is a little different than what we know before. It says the winning bid is $90. So how many bids were there? Guys, we now know that $90 was an answer, but we don't know what term it is. We're finding out the term number. So we're actually going to plug in 90 in for a to the nth term. We don't know how many bids there were, so there could have been 10, there could have been 17, we don't know. So we're going to plug 90 in for kind of that y spot on our slope-intercept form. So we have 90 equals 5n plus 55. So we go ahead and subtract, and we go ahead and solve to find out what term or how many bids that actually was. So we go ahead and subtract 55, which is 35, equals 5n. And so what we end up getting is n equals 7. So it was 7 bids that got them to that $90 spot. All right. So go ahead and answer the next question. They're just asking for, hey, the purse price is now to $105 instead of $90. So how many bids were there? You're going to plug this in to a of n again. We don't know the term number. We just know the final price. So go ahead and plug it in and see what your answer is. All right, so I got that it was 10 bids in when I went ahead and subtracted 55 from 105 and then divided by 5. So it was 10 bids that got that purse to be 105 for the price.